Welcome to Lecture 5, Stanford CS193p, spring of 2025. So mostly slides today, maybe 2/3 slides. I'm going to cover two major things here, layout and data flow. And in between, I am actually going to go to the demo and talk a little bit about assignment 1, okay? And also that matchAgainst function that I told you I would talk about more. And we'll just do a tiny bit of code cleanup if we have time. I've set an alarm here to go off in 1 hour so that I make sure I leave time for data flow. But we'll do whatever we can there to do that. All right, so let's talk about layout. So layout is about how does SwiftUI decide how much space to give to all the views, right? We've got rounded rectangles with colors in them. In your assignment 2, you've got emoji faces. So it's like, how does it decide how much space each thing gets in there? Okay, and it's actually amazingly simple process. The first thing is that container views like HStacks and VStacks and things like that, they offer some of the space that was offered to them to their subviews. And I'm going to talk about how they do that in a second here. The views, the subviews inside of a VStack or HStack then choose their own size. This is an important thing to understand, is that views choose their own size. They're not assigned a size. VStack doesn't just assign sizes to the things inside. They choose it. And why is that? Well, because nobody is better equipped to decide how big a text view should be than the text view itself, right? It knows all about text and fonts and all, so it should decide, not the VStack. The VStack knows very little about text, and it doesn't need to know. So step 2 is let views choose their own size. And then step 3 is that the container views then position the view at that size inside of themselves, right? So it's just a 3-step process. Offer space, choose your own size, place them in there. That is how layout happens. Now, each of the container views, HStack or VStack or whatever, plays this game and they make different decisions. So let's talk a little bit about how they do it. And we'll use HStack and VStack is the one you're most familiar with. And so HStack and VStack have to offer their space to the subviews inside. And the way they do that is that they offer all of their space split evenly amongst their least flexible subview. All right? So their subview that is the most rigid on its size, it offers all of them, and it might be a tie because I might have 3 things in there that have the same flexibility. And I'm going to divide it equally then and offer it to them and see what they choose. Now, what do I mean by flexible or inflexible? Well, some inflexible views that you know are like image and text. These things are very rigid, right? A text wants to fit itself exactly to the text in there, and an image wants to fit its image, whatever the JPEG is that's driving it, wants to fit it perfectly. Now, we can take these inflexible views and make them a little more flexible. We learned how to do that, right? That view modifier, minimum scale factor, remember that thing? We said 10%. That's basically saying to Mr. Text, well, I want you to be this font, but I'll let you go all the way down to 10% of that size font. So that makes it more flexible. And there's another view modifier we haven't talked about for image called resizable, that will allow the image to now scale its bits up and down, especially down. You don't want to scale an image's bits too much up or it starts to get grainy, right? But it certainly can scale down. Then there are views that are mostly flexible, like a circle. A circle, if you offer it space, it's going to take all the space you offer it, except for it's going to be 1-to-1 aspect ratio. So it's a little less than fully flexible, but it's pretty darn flexible. And then we've got the fully flexible view. The iconic one is rectangle. If you put a rectangle in a VStack or an HStack, it's going to take all the space offered to it. Whatever the HStack or VStack offered, it will always take it all. And that's why it's offered the space last. You see? Because if you offered the rectangle the space first, it would take it all, and there would be none left for any other view. So that's why it does this simple strategy, goes to the least flexible views first. So after the least flexible ones pick their size within the size they're offered some size, they pick their size inside of there. Then the VStack removes the space they chose from the space that the VStack has and starts offering the rest to the next least flexible or the more flexible views. You see how it's doing that? And it's just rinse repeat until it runs out of space or runs out of views to offer things to. That's how it works. It's incredibly, that's all there is to it. Now, after all the views have chosen their own size and the VStack puts it in there, then the VStack sizes itself to fit those views. And that's why if you put a rectangle in a VStack or an HStack, it becomes fully flexible. And you got to think about that because a lot of times you're putting HStacks inside VStacks, and you want to say, is this HStack that I'm putting inside this VStack fully flexible? Well, that depends on whether there's a fully flexible thing inside the HStack. Because, of course, we know that if the HStack has something fully flexible inside of it, when the HStack offers its space to it, it will take it all. Okay? So fully flexible views, rectangle is the most common one that we'll use in the UI, not just to draw rectangles, but to kind of make flexible space. And I'm going to show you that in the demo today. Rectangles are powerful layout tools. And so is aspect ratio. Just like aspect ratio is constraining circle, aspect ratio can constrain our views. Like our pegs, we always make them 1-to-1. And that's actually kind of nice. We don't want them to be tall rectangles. We want them to be 1-to-1. So we're constraining, making them less flexible there. There's a couple of really valuable views that I haven't talked about that you can use inside HStacks and VStacks. One of them is spacer. Spacer is kind of like a rectangle that is drawing clear, except for that it does have this min length thing, which means it'll be a minimum amount of size, right? And use spacers to put spaces between things in HStacks and VStacks. But it's like a rectangle in that it's fully flexible. So if you have an HStack and you put a text and then a spacer and then a text, the two pieces of text will get slammed to the outside, to the leading and trailing, because the thing in the middle will grab all the remaining space because it's fully flexible, okay? Yeah?
I have a question. How can we make sure that things don't overlap each other?
Yeah, so the question is, how do I make sure that things aren't all overlapping each other inside my UI? Well, the whole SwiftUI mechanism, that thing I just talked to you about, is fundamentally built not to overlap things, right? Because I offer space to things, and when they take it, I take that space away, and now I'm offering the remaining space. So hopefully you don't have a lot of, were you having a lot of overlapping problems?
No, but I was just worried.
Yeah, you're worried it was going to happen. But it's surprising it won't happen that much because of this strategy, right? Where we give space, and then we take it away, and we're only giving the remaining space, so they can't overlap. Now, views are allowed to draw outside of the space that they were given. That is possible, but very few views do that. It's rare for a view to do that. And the other one is divider. So divider draws a little line, a little kind of gray line between the things. And it's fully flexible in the crossways direction. So in a VStack, it's fully flexible horizontally, but it's not flexible in the vertical way. It's only the width of that line. So divider is how you can put dividing lines in between things in an HStack or VStack. Common to use these two things to arrange things in your HStacks and VStacks. Now, that whole thing that HStack and VStack do, where they do least flexible and all that stuff, can be overridden. You can control it with this thing called layout priority. So this view modifier, if you put it on a view, the default layout priority is 0. So all the views are doing the least flexible thing I just talked about if they're all layout priority 0. But if you bump one up above 0, and this is a floating point number, so you could bump it up to 0.1 if you wanted, that would be more than 0. That one will get priority, and it will be the first one offered space. You see? And so in this case, I've got a text, an image, and another text. One of the texts is really important that I see the whole thing. And if I'm space constrained or I can't fit all these three things, because what happens then? If you can't fit all these three things, then after the HStack, or in this case, offers space to the first two and it runs out of space, it's going to offer too small a space for that last text, that unimportant. There's just no space left in the HStack, so it offers too little. Now, what do texts do when they're offered too little? They size themselves to be too little, and then they use ... So you see in my slide there in the bottom right, Swift is ... instead of Swift is great. And we actually saw this in the demo. We tried to put our guest button, remember, in the UI, and we tried to make it 80-point font, and it just put ... because it couldn't fit that in there. Layout priority can just override this whole thing of who gets offered things first. And the layout priority can be positive or negative. So negative things are very low priority, and positive things are very high priority, and 0 is equal priority. Now, it's time to talk about other container views, other instruction manual Lego views than VStack and HStack. And it's the only ones we've used, and they are by far the most common ones we use, HStack and VStack. So don't feel like you're missing out. 90% of the time we're using those things. But here's some other ones. LazyHGrid and LazyVStack. So why is it called lazy? Well, these are lazy because these are VStacks and HStacks where if the views are not on screen, it doesn't lay them out. It doesn't offer them space and how much space do you want and all that stuff. So imagine you have a scroll view with all your iPod songs, 10,000 of them. It would be horrifically inefficient if you laid out 10,000 little things saying this song and this album. You see what I mean? That would be ridiculous. So you would use a LazyVStack in that case, and it would only lay out the first 10, and then as you scroll down, it would start laying out the other ones on demand as it went through. Now, one thing that's interesting about these is we know that a VStack, if you put a flexible thing in there, it gets flexible and gets as big a space as it can do. And this is kind of the exact opposite. A LazyVStack tries to be as small as possible. So if you put a flexible size thing in a LazyVStack, it might squish it down to 0. And that's because it knows it's going to live in scroll views and stuff, and if you're scrolling, things are too big, so it wants to be small. So LazyHstack and VStack, use them in scroll views all the time. They're common to be used in scroll views. Then there's LazyHGrid and LazyVGrid, which are almost exactly the same as LazyHstack and LazyVStack, except it lets you put more than one view in the opposite direction. So if it's a LazyVGrid, you can have 2 or 3 items per row, not just one item per row like in a VStack or a LazyVStack. And how you place those things horizontally, you get to control that. There's an argument to its initializer called columns or rows if it's HGrid versus VGrid. And that argument says things like, well, when you put things across here horizontally, this one should be flexible size, this one has to be exactly this size or whatever. Just some coordination to say what they are. And then what happens is you have your LazyVGrid and you just give it a whole pile of views. Right, a whole bag of Lego full of views, and it just starts laying them out. 1, 2, 3 across, goes to the next one. 3, 4, 5 across, you see what I mean? It's just pouring them in. It's almost like the way text runs on a page, where it's just laying them out like that. So it's called a grid because, yes, it's a vertically growing stack, but since it has some horizontal elements to it, it's kind of a grid. But it's not really a strict grid like a spreadsheet or something. There's another thing for that called grid. And grid, you could even almost think as spreadsheet or table view or something like that. It's for when you have rows, repeated rows usually, that are usually showing the same kind of data over and over, and you want to be able to line up their columns or even line up like the decimal points in the numbers, like in a spreadsheet, right? If you had numbers in a spreadsheet, you line the decimal points up. Grid lets you do that. And the way grid works is it's a container view, but it always contains this other kind of container view called grid row. So each row has a grid row, and that grid row is almost always in a for each, which is showing each row. So the grid row specifies how each row is laid out, where all the columns are, and the grid is then combining all the grid rows, and again, it's usually for each. The thing about grid to know is there's a lot of view modifiers that help you control things like lining things up inside the columns, and they all start with .grid. So if you go look in the documentation, .grid something, that is going to be a view modifier that is going to affect the way this view appears when it's in a grid row in a grid. This is how you lay things out kind of vertically and horizontally in tables and all that stuff. What else is there? Scroll view, you already know about that one. Super simple. I think it only has one argument to it, which is whether you're scrolling horizontally or vertically. It also does have a lot of .scroll view modifiers that control how the scroll view works, like where are you scrolled and things like that. So if you start doing more sophisticated scroll view, you'll get into that. But amazingly, scroll view just works most of the time without using any of the .scroll position or whatever view modifiers. Then there's a really cool one called ViewThatFits. So ViewThatFits, you give it a bag of Lego, and instead of like organizing them in a vertical stack or something like that, it lays them all out separately and picks the one that fits the best. And this is super good for things like portrait versus landscape. You could imagine having your data and you put it in a VStack and you want that to appear when you're in portrait mode because the phone's kind of tall and skinny, or an HStack so that it appears in the other way. Or you might even not be quite sure and you might make 3 different things, a VStack and then maybe an HStack with 2 VStacks in it and then another HStack that's no VStacks. You see what I mean? You can kind of lay it out a bunch of different ways and it'll lay them all out, and this one fits the best. And fits the best means views aren't clipped and they fit and they're using the size that they want. That kind of logic. So it's pretty smart about that. Then there's kind of the granddaddies of the containers here, form and list and outline group and disclosure group. form and list are kind of combinations of VStack and scroll view and divider and a whole bunch of view modifiers to be able to present things in a consistent way across applications. Form is for presenting things like settings. What do you have in settings? You got text fields you can type, you got checkboxes, you got on-off switches, you got all kinds of things in there for entering information into a form, electronic form. And form makes it so you just put them in the bag of Lego and it just lays them all out perfectly, separates them, puts dividers between them, makes them look the right way to all live in a form together. So that's form. We'll be doing form in CodeBreaker, believe it or not, in a couple weeks. And then list is for long lists of things, so it's kind of like a big VStack in a scroll view, except for that it automatically puts the dividing line in there. It does selection, so you can click on things in the list and it keeps track of what you selected. It's got a lot of .list things for styling it, how you want the list to look. So list and form, and we'll use list in CodeBreaker as well in a couple weeks, they're really important. They're fundamental to building the core of your app usually. Outline group and disclosure group, that's if you have hierarchical data, like let's say you were building an app that showed the file system. You got folders inside folders and files inside folders. And disclosure group is part of that because when you click on the show me what's in this folder, it discloses it to you. So that's what a disclosure group does. It lets you increasingly go down some hierarchical data, disclosing it as you go. Probably won't get to those in this class, but they're pretty easy to use, especially once you understand form and list and things like that. It's just got some things to think about. Now, all of these things, HStack and VStack and all the things you see here and all the things on the previous page, they're all implementing a protocol, okay, it behaves like, called layout. And layout has things in it like size that fits and place these subviews and all that stuff I was talking to you about, the dance of offering space and do it. That's all part of this protocol. And you could implement your own container. Now, you're not going to do that in this class, I guarantee you, not even for your final project. It's a little bit sophisticated, SwiftUI. But I just want to let you know that's what's going on behind the scenes here, is that there's a protocol that these things are behaving like so that they can play that dance. Now, I want to talk about ZStack a little bit specially here. I think you already understand that ZStack is like HStack and VStack. It's just that it stacks the views towards you as the user, stacks them on top of each other. It sizes to fit all its children. So if it has a flexible view in it, it also will be flexible because it's going to give all the space that it has to its flexible view, and that flexible view is going to make it flexible. So ZStacks with flexible views are also fully flexible. But there's kind of an interesting case if you have a ZStack of only two things. And we've already seen it. It's overlay. Overlay is just a ZStack with two things in it, where one is overlaid on the other. But the trick here is that the sizing is only happening with the circle here in this case, not the thing you overlay on top of it. It doesn't matter what you overlay on top of it. It has to fit in however the circle was laid out. So this whole line that you see right here, circle, overlay, alignment center, text hello, that is going to be laid out in a VStack or an HStack just like it was a circle. The text had nothing to do with its layout. And then after the layout decisions have been made, the text is plopped on top of it. And this alignment says where the text appears, because it might be smaller than the circle gets laid out to be. And so there's center, there's top left, bottom right. You can put that alignment anywhere you want. So does everyone understand the difference between a ZStack of two things and overlay? It has to do with how the space is allocated. It's just allocated to the circle here. And similarly, there is something called background, which is the same thing, except for that the other view is behind. So in this case, this background one, the text hello, it determines the layout. And this rectangle foreground color red goes in the back. And it would be the size of the text, because it has to live with whatever the text got laid out to be. And this is really valuable for debugging. Why is this valuable for debugging? Sometimes you have a lot of views on screen and you're just not sure which view is drawing what because it's all spaced out. Maybe they're not spaced the way you want. You're like, why is that so spaced out that way? And you want to understand. Just pick key views and put .background red rectangle or green rectangle or yellow rectangle, and it will fill the entire view because that's what background does. It makes that rectangle obey the layout of the thing that you put it on. So adding .background rectangle foreground color, some color, and maybe even two or three of them with different colors to different views in there is a great way to see what's going on. A great debugging thing. Because debugging views is not always so simple and so easy. It's not quite as easy as debugging imperative code. You can't use the debugger as much, right? Because all your views, their code is only being run when the system says, I need that var body to be rebuilt. And it's not always rebuilding every var body. It's only rebuilding the var bodies that actually have changed. So sometimes it's a little tricky to think in your mind, well, which actual helicopter view is changing here? Whose var body is getting rebuilt? And so it can be tricky. But this is a great way to just see who's drawing what. The other thing that's sometimes hidden is that view modifiers are involved in layout. A view modifier like padding, let's say, it's almost like padding is a little container that contains the thing inside of it with some padding around it. So you can kind of think of it as a container view, and it kind of plays this same game. But other view modifiers like font, no effect on layout. They're just absolutely not involved in any way in it. Even though they affect the way the text draws, that's up to the text to make that decision. Font modifier itself doesn't actually do it. But padding and aspect ratio are two great examples of things that do affect layout. So let's look at padding and how it plays the game of offered space. You see what we have here, text with padding 10 around it. Everyone knows what this does. It takes a text and it's going to put 10 points of padding around all sides of it, so it can make it bigger than the text. And I might be throwing this into a VStack or an HStack. In fact, imagine this whole yellow thing is a view. I'm going to call it the yellow view. And in fact, it is a view because padding is a view modifier. What do view modifiers return? A view, right. They return something that behaves like a view. So that yellow, that entire expression, is a view. So we're going to talk about how that view participates in a VStack with the layout system. First thing is that yellow view's flexibility. Well, it inherits that from the text. If the text is something flexible, then the padding is going to be flexible. And text is not, so this padding will not be. That entire yellow view is not going to be flexible. So it will be offered space first. The whole yellow view will be offered space first. Then during layout, as the yellow view is offered that space by the stack, it'll take the space that's offered to it and then turn around, reduce it by 10 points, because it knows it has to pad it by 10 points. So it reduces it by 10 points and it offers it to the text. And then the text chooses its own size, and then the padding adds the 10 back. So if I had this yellow view inside of a VStack and there was a lot of space to be had, this whole yellow view would still be pretty small. It would just be 10 points bigger than a text would be in there because it would size itself back down. That's how it plays the game, exactly how you would expect there. So view modifiers can be involved. Now I'm going to go back to the demo here. The first thing that I want to talk about is assignment 1. And one of the things that happened in assignment 1, remember, I know you're all working on assignment 2. I know. You probably are already almost done with assignment 2, right? But anyway, assignment 1, if you remember it, you were doing the match markers. Right? You put those match markers in there. And a number of you really did a great job with that. And there's an old saying that I worked with a guy who used to love to say this all the time about almost any problem, that there are only 3 numbers in computer science. Has anyone ever heard this? You know what the 3 numbers in computer science? Only 3. There's 0, 1, and n. And that your code should always only do one of those 3 numbers, or all 3 of those numbers. And what that means is that when you have a problem like this match markers, it should work if there's 0 match markers, it should work if there's only 1, and it should work for all other numbers. And some of you did that. And the way you did it was really smart. Let me match markers up here. You had in here in the body, you just did a couple of for eaches. And then the matches could be anything. And it was fantastic. It really showed me you really understood what we were doing. So all of you who did that, kudos. I wasn't really expecting that. I was just expecting you to put a little if right in here that says if there's 5 or 6, then do another VStack. I would have been fine with that. And those of you who did that, you did a great job too. But you for each people were doing the 0, 1, or n, and you did n. Unfortunately, when you did the n, you broke the 0 because it left you in a case where when matches was empty, you drew nothing. You had no views because you had 2 for eaches, and those 2 for eaches never created a view because there was no matches. So I know some of you had this problem, and we talked about it on Ed Discussion, and we went through different solutions, like maybe we make it so that even if matches is empty, it always draws at least one. That would work. Or some of you went back, and instead of having matches be empty for a master code or a guess, you had it be .nomatch, 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 right? 4 .nomatches. That solved the problem as well. But I thought it would be good to talk about, okay, what would be really a good solution to this problem? And why are we having this problem? Why did the zero problem happen? Well, really what we did to match markers by doing for eaches is we made it so that it behaved differently in the zero case in terms of its layout. Right? I just talked to you about layout. And match markers went from fully flexible to completely inflexible zero size. And it just depended on the argument you passed. And generally, you don't want to do that. Views generally want to behave the same, 0, 1, or n, in terms of their layout, generally. And I say generally because I bet there are cases where, no, you wouldn't want to actually do that. But for the most part, you'd want to do that. Again, a way to solve this here is you could just say, if matches is empty, then do a clear rectangle. Else do this. That would be one way to do it. Or like I say, this one here solves the problem, because here I always do put a circle for every match marker, whether there's none of them or not, that circle down there. But that circle sometimes is filled and stroked with clear. So it's still there, still taking up space. It's still causing this to be a fully flexible VStack and HStack, because circle is fully flexible within the aspect ratio. So this actually solves the problem. But with the for eaches, you might have to put some extra if in there. But I actually want to step back and ask, were we right to make it so that over here in our model, where we had code and we had matches here, we return empty array when it's a guess or the master code? Was that correct? Was that really semantically right? And I'm going to claim no. Why? Because guess and master code do have matches. So to say that their matches are nothingness, it's just not quite right. Really what we're trying to say in this matches var is, for guess and master code, this makes no sense. It makes no sense to ask for the matches of the master code. We know what that is. And it makes no sense to ask for the matches of the guess. You're not supposed to know that until you make an attempt. So what type do we all know that we often would use when something makes no sense? What would that be? Optional, exactly. We use an optional. And so I would suggest that the way to do this is actually have matches here return an optional array of matches, and that if it's not an attempt, then this, instead of returning empty, would return nil. Basically returning here from matches saying, this makes no sense. You asked for the matches of this code, that makes no sense. That's because it's a master code or a guess, but it makes no sense. Now, if we do this, of course, it breaks our code back here, because matches, the match markers, it takes an array of match. It doesn't take an optional array of match. So you can say value of type optional match question mark must be unwrapped to a value of match. By the way, that phrase unwrap, that means using exclamation point or if let or something like that to get it out of there. If I can let matches equal the code's matches, so I'm unwrapping this code.matches, which is an optional, we just changed it to an optional, then I'll put this in here. So that fixes the compile time error. What happens on the right? Uh-oh, that didn't work, because where's my guess button? And my pegs go all the way across. So this is exactly the problem those of you who use for each were seeing right here. This is not fixing the problem, because what if code.matches is nil? Then we don't even do that match markers thing. So if that match markers thing is nil, we need to do something else. So maybe we could try this. Else, put this in there. This is that guess button. So let's put the guess button in. Right? Whoops, that didn't do the right thing. It put the guess button in, but it's huge. Why is that guess button huge? Because the guess button is a button with a font of 80. And yes, it'll scale down to smaller, but it's using all the space it can get its hands on right there. And there's plenty of space down vertically. So that's not really doing what we want either. Really, we want that guess to stay in a space that's the same size as one of the pegs. And look at these pegs. They are rounded rectangles. This is one peg. This whole thing right here is one rounded rectangle. That is one peg. So the right solution, I think, here is to have this code right here, all this right here, be overlaid on a clear rounded rectangle. Because by definition then, my 4 eaches that have the round rectangle is going to be treated the same in layout as this match markers area with the guess button. So I can do that really easily here. I'm just going to say, create me a rectangle which has a foreground style of clear, and I probably want it to be square to match this guy's aspect ratio up here. See, he's square, so I'm going to have mine also be square. Content mode fit. And then I'm just going to overlay this thing on top of it. So because we know overlay gets its layout treatment from that rectangle, this just works. Look at that, it works perfectly. So this is probably the best solution, mostly because I'm matching this with the ones inside the 4 each. So I'm getting what I semantically want, which is 5 spaces all the same size, the 4 pegs and the markers or the guess over here. And so hopefully if I put a guess in here, the match markers are also fitting in that little space, and they are. And if you get weird sizing and like things aren't sizing the way you want, then you want to start thinking about the layout. How's this being laid out? What's fully flexible here? What's not? Kind of walk it through in your mind. All right, let's go do this match against. I posted on Ed Discussion, I said, go look at this and see if you can figure out how it works. How many people did that? Okay, about half of you. So I'm going to quickly go through how match is matching against this other code here. And it's taking the 2 codes and returning an array of matches with exact or inexact or no match for each of the pegs, whether it matches the other code. So I'm starting out by creating a writable, see it's a var, array of match, which starts out all no match. And then I'm going to make 2 passes, one to find the ones that are exact matches, and a second pass to find the ones that are inexact matches. Along the way, I have this pegs to match, another writable, you see, writable array, which is the pegs in the other code. And the reason I need this pegs to match is every time I match one, I'm going to take it out of this array of pegs to match, because I never want any peg to match twice. Like it's an exact match, and then later it comes along and it matches inexact from some peg at another spot. I don't want that. So every time something matches, exact or inexact, I take it out of the other code so that I can't match it again. And the way these for loops work, we only for over collections. That's the only kind of for we have in Swift. So we are here foring over the pegs indices. So that's the 0, 1, 2, 3 of the pegs. And we're reversing it. And I'm going backwards because I'm going to be removing those exact match pegs, and I don't want to be removing it from the positions that I'm just about to check. So I'm going to go backwards, and I'll be removing the pegs at the end. And then inside this for loop is really easy. I'm just saying as long as the pegs to match have this index, so here I'm just making sure I don't get an index out of bounds error, then I'm going to look in the master code and see if it equals my pegs. Everybody got that? And if it is, woohoo, I have an exact match, and I remove it from the pegs, because I'm removing every time I have a match. And then, once I've got this results thing up here, now is a mix of no match and dot exact for the ones that are exact. And then in here, I'm just going through the indices again, and I'm saying if I didn't have an exact match for this peg, then I'm going to look in the remaining pegs. Okay, these pegs to match are the leftover non-matching pegs. I'm going to see if it's in there. And if it is, now I have an inexact match, and I'm going to remove it from the master code. Pretty simple. This is not super sophisticated. But I actually want to change this and show you how we would do this with functional programming, because functional programming is a skill you're going to have to eventually master in Swift. So here I'm just going to show you an example of taking this exact code, same strategy, everything the same, but I'm going to do it with functional programming. And it's really easy, and it actually makes this code look a little bit nicer. The functional programming function I'm going to use here is called map. Anyone who knows about functional programming in any language knows about map. Map and filter and reduce are probably the 3 fundamental ones there. But what map does, it's really easy. It's a function in a collection, like an array or a range or something like that. And it has only one argument, which is a function. And that function takes an element in the array and it returns something new. And then it makes an array out of the something news. So it converts one array to another array. From one type, maybe to another type, or maybe the same type but different values. It's an array converter. And it does that conversion by calling a function over and over on every single thing in the array. And what we're going to do in the first pass here is I'm going to find all the exact ones by mapping from the indices in the pegs to the match. And the match is either going to be exact or no match, because this is only the first pass. The function that I'm going to pass to map is going to take an index, because I'm going to do it on the indices, and it's going to return a match, either exact or no match. And we do almost exactly the same thing here. We're going to take our pegs indices reversed right here, and I'm going to let exact matches equal that, and then I'm going to call map, and I'm going to give it a function here, this inline function, a closure. And this map thing takes something from the original array, which in this case is an index, one of the peg indices here. And then I can actually do this code down here, basically. I'll copy that, paste it up here. I'm going to do all the things I'm doing here, except for that instead of setting this in a results, I'm just going to return exact from this closure. So I'll have to do this first and return exact. Now, notice that it complains, hey, dot exact, what is that, dude? Well, I haven't given enough information here to know what map is converting to. Converting from the indices, but it doesn't know what it's converting to. So I actually am going to have to say here, match dot exact. And when I say that, now map knows what to do. It knows it's creating an array of match, and so it's able to do that. Now, another thing here, it says, you are missing a return value, because I only return this match.exact if it's a match. So I also have to say, if it's not a match, return dot no match. And here I don't have to say match, because Swift can already infer from the other return that that's what we're building here in this map. So I can just say return no match. So now I have this no match, and I don't need any of this. And this var results right here that started out as no match, we could actually make that be var results right here. And so results is just going to start right off the bat being an array of matches with no match and exact. You know, I could also make this second part down there be a map as well. And so how would we do that? How about this? I'm going to return the pegs indices, and I map those as well. Index in. And in this case, I'm going to use this code down here again. Let's take this code, put this up here. And I'm going to change this var results here to exact matches again, because I actually don't need var results for this, because I'm just going to return this map directly. So here I'm going to say if the exact matches at that index is not exact, then if it matches in here, then I'm going to return inexact from this closure, and also do that remove. And actually, let's combine this. Watch this. Put this here, comma. Someone was asking about this before, so we'll talk about that in a second. So I'm combining those with comma. Comma means and when you're doing if. Otherwise, I'm going to return the exact matches at that index. This one also, notice I didn't have to say match.exact here, because this alternative one I'm returning exact matches, which is known to be, if I option click on it, array of match from this one. Okay, so I don't need any of this, don't need return results. And here with two maps, I've mapped the exact matches in the first one, and then the second one I've just returned another map that maps from the pegs indices to the exact matches. But there's one slight problem here, which is that this exact matches was reversed. So we did calculate the exact matches properly there, but they're in reverse order. And having this exact matches thing be reversed, it make it so it doesn't work down here in this map, because it's using exact matches. So we need to reverse it back, essentially. So let's call this backwards exact matches, because that's what that one is. And then I want to say let exact matches, the forward one, equal the backwards one. And you can see AI here wants to say reversed. That is kind of what I want, but I have an error down here when I do that. And what does this little error say? It says, cannot convert value of this whole long thing into this thing it calls reversed collection. So you see where it says reversed collection there in that error? So reversed, this little function reverse that we have right here, it does not return an array. Even though I'm reversing an array, it actually returns this thing called a reversed collection. Now, a reverse collection is a collection, just like an array is a collection, a set is a collection, ranges are collections. So it's a collection, but it's not an array, so we can't do this. We can't do the square brackets indexing into it, right? The normal array, give me a thing in an array. So this has to be an array, and it's just a collection. So luckily, array has an initializer that you can give it any collection, and it will turn it into an array. It just goes through the collection, grabs all the things one by one, and puts them into an array. And you might ask, why does reverse do that? Why doesn't reverse just return an array? Well, imagine the array was huge, and you had to reverse it. Are you really going to turn around and make a new array with all of them copied? Instead, it just probably really smartly keeps track of the other array and the fact that it's supposed to be backwards, and then just gives them out backwards. So when we do this array of turning it into an array, we probably are copying all the elements. Totally irrelevant to us. We only have 5 or 6 at the most matches in here, so we really don't care. But this is not even what I wanted to show you today. And you can go noodle on that later and convince yourself that this works and try to understand map. But I actually just want to point out something really weird about this. I, in map, am calling this function inline. And look what I'm doing inside of a function that I'm calling. I'm actually modifying this var. See that? This is a read-write var, local variable in match, and I am modifying it inside a function I'm calling. Now, it's an inline function, but still it's a function, so that's just weird. Does that strike you as weird or not? No? Yes? Some no? But some might say, oh, this seems perfectly natural, which is great that you think it's natural, because what you're saying is closures are very natural, which they are. But it's just weird that you can access that local variable and write to it in a function that you're calling right in the middle of this code. But that is an important thing to understand about closures. Closures capture the environment that they're operating in. They capture all the local variables, and you can write to them. The whole word closure, you might say, where does that come from? It's because this is a closed lexical space that includes all of those things. That's the kind of more technical answer here. But you can kind of think of the word closure as like the word enclosed. And these closures, these inline functions, are enclosed in the same lexical environment as the thing they're in. That's why you can access their local variables. And it is very natural. It's incredibly natural that you're able to do it, but it's pretty cool when you think about what's actually going on there. You're calling a function. You can actually access local variables from the outer scope. I just wanted to show you this to you now so that you know it's there. We'll be doing this as the quarter goes by, but this is just your first shock treatment on functional programming and closures. So don't get too freaked if you're like, I didn't get that. So you can look at it later.
Yeah. Two questions. First, before we had variable results.
So the question is, what happened to var results? We had this var results. It was a writable array of match that we were writing to. Where did it go? Well, it got replaced by a read-only one. See, it's a let, which is the no matches and the exacts, not the inexact matches. And then the next thing is we did a map of the pegs indices again, where inside there we looked at that exact matches that we already created inside that closure. So once again, we used local variable exact matches inside the second closure. So in the second one, where we're mapping from pegs to matches, there, if it's already exact, we just return it. Otherwise, we look to see if it's inexact, and if it is, we return that. And otherwise, we just return no match, because it was neither. If you look down at the bottom one, look how we're referring to exact matches there. So we didn't need the results, because we were doing two maps. And one great thing about functional programming, a lot of read-only data structures. We don't need as many var results accumulating things. We have these nice read-only data structures that are being returned from functions and passed to functions and stuff like that. And the second question?
We wanted to store for each map what was the result, but right now it feels like we only return one map.
Yeah, so the question is, where's our for loop, basically? It seems like we're just doing this in batch processing or something instead of doing the for loop. And the answer is the for loop is inside the map function. Because the map function in a for loop calls its argument right there repeatedly on everything. It does a for loop over them, so it's built in. I think I have about 3 minutes here before I have to go back and talk about data flow. So which of these things am I going to do? Let's do a quick one, which is a naming thing. So I did a naming thing that I didn't like, and so I'm going to go back to it. And that is right here. You see this? I called a missing peg missing inside of code. But look how it reads in my code. Code.missing. That looks like it's a missing code, not a missing peg. So I really think I should have called this thing missing peg. So I'm going to refactor, and whoops, not distract file. I'm going to refactor and rename this and call it, after it finds all the cases of it, missing peg. Code.missing peg. Another thing I could have done is actually add an extension to color that added it there. Watch this. Extension color. Let missing color.clear equal color.clear. It needs to be equal there. Equals. And now I could actually call this, instead of code.missingPeg, peg.missing. So it's a missing peg. And peg, of course, is type alias to color, so I could even say this. Extension peg, because same thing, it's a type alias. Yes, sorry, static. Static. A static let, just like my static let on code. So I could have done that as well. And I think that would have been good too. So kind of out of time to go change it to that. But you see what I'm talking about naming here? Naming matters. And I really want you to really think about naming, not just in this class, in your entire computer science career. Pick good names. Back to our slides. So data flow is crucial to building apps that are reliable and debuggable and that you can figure out how they work and all that. So let's talk about the kind of data that flows throughout your app through all your views. So one kind of data flow is data that flows into a view, just only in, and it's read-only in there. Okay, view gets it. This is like match markers takes the matches. Okay, and how is that declared? Let matches colon array of match, and it has no equals, so it has to be passed in when someone creates a match markers. That's data in. Everybody understand that? Okay. Then there's data owned by me. That's data for which I own the source of truth. That's like @state. @state game equals code breaker. Okay, that view owns the game. All right, so we're going to talk a little bit about that. Then there's data I/O. This is data that is shared with your view. So this data, you get it and you can modify it, but you don't own it. You are not the source of truth. Somebody else is the source of truth. Okay, it's being shared with you. So we're going to talk about how that works. We have not seen that at all in what we've done so far. And then this is functional programming. So sometimes we pass data in and out by calling functions. Okay, and we do this by having lets in our views whose type is a function that returns some data or a function that you pass some data to, and then the view can call that function to get the data at once or return some data at once. You see what I'm saying? And you have actually seen this. Can anyone tell me something that we've seen that uses a function to pass data to a view? Yeah, exactly. View builders like VStack. The third argument to VStack or the third argument to for each, that's a function. And, for each or VStack calls it to get the view, the bag of Lego that it wants. And why does it do that, by the way? Because it wants view builder to work, and view builder only works on functions. So that's why that argument is a function. So you have data in functions, data out, and then I'm just mentioning this. It's not really data flow per se, but of course sometimes your view has an action func, a func that just gets called when something happens inside your view. Okay, update this or something like that. So sometimes you'll have that. Action functions often take no arguments and return nothing. Like button has one of these, right? Button has an action. That's the thing that the button does when you click on it, right? So other views could have that kind of behavior. Now, I would like to install a discipline in the class if we could, and this is new for me too, and I'm probably going to forget to do it over and over, but hopefully you'll remember to do it in your homework. But the discipline is to just put all of our data flow things at the top of our view. Okay, all our data in, our shared data, our @sign states, all of them at the top instead of spreading them out below, which is legal, but we're just going to put them all at the top, and we're going to put comments. These / mark comments, which I'll show you in the demo on Wednesday what that mark thing does. But a little / marks data IO. This is a data IO section. This is the data in section. This is the data out functions. We're just going to mark them. You see what I mean? Just so that we are cognizant, oh, yes, I'm doing data in here. I'm doing data IO, etc. It's going to be a little excess code typing in comments like this, but I think the discipline might help. So we'll try it this quarter, and we'll see. I've never done it before this explicitly, but we'll see how it goes. And if I'm in lecture and I'm not doing it, you can remind me, hey, how about a comment there, okay? And we'll see if together we can do it. But go ahead and try this in your assignment 3, let's say. Start it in assignment. Don't worry about it for assignment 2. Or do it in assignment 2 if you want to, but anyway. All right, so let's talk about these things. Data in, as I said, it's mostly like let matches is an array of match, and you pass it in. Of course, we know it also could be var matches, array of matches, equals something, which is almost the same, except for there's a default value now. And so someone could say, I don't want to provide that var, right? So does everyone understand the difference between having a let and then having a var with a default value at the top of your view? Yes, I don't see a lot of nodding heads. No? Okay, well, maybe we'll show that on Wednesday. But, I mean, you all understand that let at the top of your view means someone has to pass this to me. Okay? Well, var means that too, except for a var could have an initial value, right? That would be a default. That's all I'm saying there. Of course, if you have an init in your view, we haven't had any views with init yet. We had our model had an init, but not our views. But views can have inits, and you could pass data in through the arguments of init, obviously, initializing your view. But there's another kind of data that comes in to your view we're talking about here, which is environment values. Okay, values about your environment. So sometimes your view to draw properly might need to know what environment it's in. So some examples. Am I in dark mode or am I in light mode? Okay, accessibility settings for visually impaired or other kinds of things. Am I the active application right now or not? Okay, how much horizontal and vertical space do I have to draw? Okay, am I in portrait mode or I'm in landscape mode? What locale am I in? Okay, what part of the world is my user? There's a thing called an undo manager for managing undo in your app. Things like font and minimum scale and dynamic type size and line spacing, things like that you set with these view modifiers, they're part of your environment as well, right? Because remember I set a font of 80 point on a button. It knew to pass that along to its text. That's because that was part of its environment. It was part of the button's environment, so it became part of the text environment. So these environmental things you want to know. And they all live, all of them, in a single struct called environment values. So go to the documentation as soon as possible and go look at environment values, and you will see a big long list of vars in there, an explanation of all of them, and you'll see color scheme for dark and light mode and all these things in there. But the interesting thing is we do not access environment values directly. You don't like create one of these structs and get its values or anything, or get one of these. Instead, we access it with this @sign thing called @sign environment. Okay? And @sign environment takes one little argument there, which is the name of the var in environment values that you're interested in, and then you give a local name to it, basically a variable name to use inside your view, which is usually the same name. Doesn't have to be, but it's usually the same name. And then inside your view, you can now see the color scheme, the dark and light mode, color scheme is dark versus light mode, of the environment your view is running in. Okay? So I might have my var body draw a moon, and if I'm in dark mode, it's a yellow moon, and if I'm in light mode, it's a blue moon, okay? And I can do that by just looking at my color scheme, right? And so there's tons of things. I mentioned a bunch of them on the previously, but there's probably close to 100 different things in your environment. And you can add your own environment values, amazingly, okay? Things that you want to be in an environment or view. You do that with an extension to environment values, obviously. And there's this nice little @ thing called @entry, and you just say the name of the var, like var words or var color scheme. But you have to give a default value, because when people look in your environment, they have to see at least a default value. But this value also can be set, though. By the way, you're rarely going to do this. You won't do it in this class. I just want to let you know it can be done, but you don't do it. So how do these values get set? Well, of course, a lot of them, like color scheme, are being set by SwiftUI. It knows what the color scheme is, and it just sets it in your environment. But you can override that with the .environment view modifier. So .environment takes two arguments. The first one is the name of the var, like color scheme, whatever, and then the second one is the value that you want it to do. So if I did this, match markers, environment, color scheme, dark, match markers would think it's in dark mode. No matter what the phone actually was, it would think it's in dark mode because I changed its environment, you see? And so environments are view specific. Each view has its own environment, and you can tweak its environment. And again, that's why with the guest button, when I said .font 80-point system font, that became part of the environment of the button. Okay, no other views, just the button. And since it was environment a part of the button, that environment passes down to all the subviews. Okay? So your environment works for you and all your subviews, all the things in your var body get this environment. So this is a really cool feature, the way you can kind of have this environmental data flowing down through the views. Okay? All right, we don't call .environment very much, but we are going to call it a couple of times in this class. You'll see where we use it. All right, let's go to the next. So that's data in. That's how data comes in. Either as a let or a var or an init argument, or it's an environment data coming in. Then there's data that's owned by the view. This is @state. You know this well. Makes sense. One thing I do want to emphasize, we do not generally use @state to hold our model like we're doing. Okay, we're doing that because we're too early in our understanding to do it any other way. But generally what happens with our model is it is given to us. So if you have a code breaker view, it's almost always going to have a let, which is the model, the code breaker to show. You see what I'm saying? A code breaker view is a thing that visually manifests a code breaker. And so usually it's a thing where someone gives it to you and says, please visually manifest this for me, right? It's rare, it's not normal to have it being stored inside the view like this in @state, which you can kind of understand because @state gets thrown in the trash as soon as the view goes off screen. So imagine you had a more sophisticated app that lets you play multiple games of Codebreaker at the same time and switch between them. Well, with our system, every time you switch to another one, the last one would get thrown away because that view would go off screen, kaboom, it's gone. So that's no good. Right? You would want those games stored at a higher levels, where some storage is, and we're going to do this in a couple weeks, and then asking the codebreaker view, please draw this codebreaker for me. Okay, so I just don't want you to get the idea this is the way you do model, is put it in @state. It's demoware. Okay, we're going to get rid of that soon. So what is @state used for then? If your model's not in there, well, it's used for UI things like what's the current selection, or how am I supposed to be sorting this, right? If I'm choosing between sorting methods, or a search string I type in to search through my data, or a Boolean that says whether an alert should come up, or other things that have to do with just configuring the UI, temporary things that are only state when you're actually interacting with the view. Because @state is view state, and views are temporary. They come on screen, they do some things, they go away, right? They come on screen, they do some things, they go away. That's the way views work. We have a simple app where a view comes up and it's up all the time for the entire lifetime of the app because it's our only simple little view. But ours is a very simple view so far. And we will, don't worry, Codebreaker is going to be a really powerful app with multiple views and forms and all kinds of stuff going on. But right now it's in simple mode. Note, I just want to emphasize the private, @state private. I told you this before. Always put private with @state. Just always do it. Okay? Because if you don't, you're just going to expose that var to people creating you, and they might think they can set this var, but they'll only be able to set it once because you own this data. Okay, once they've said it once, even if they try to set it again, not going to work because you have taken ownership. You are the source of truth. So don't make that not private. Always private, always private. The other minor thing about @state is, remember, if you have @state that's a dictionary, an array, all the things in there, you own those too. You're the source of truth for those as well, right? You're a source of truth for the array itself, but also all the things in the array. You're the source of truth for that as well. And it's not unusual to have @state that's an array, but just recognize that that's what's going on. All right, now let's talk about the big thing of the day, which is share data between views. How do we share data between views? We do this with another thing, @binding. So @binding is like @state, very similar, except for the source of truth lives somewhere else, and you're going to bind to it. Right, so let's talk about how this works. I have view A here. View A has a source of truth called my data. It's an @state. You see it's equal to 42 there initially. And it wants to share that piece of @state with view B. In other words, it wants view B to be able to change my data, change it from 42 to 27 or something like that. And the way it does that is it creates view B with this argument foo, which is an @binding. So there's view B. See, it has @binding var foo. It's not set to anything, so we have to set it when we create view B, which is what we're doing right there. And the value that we're going to set foo to is $my data. $my data means a binding to my data. Okay, that's what at some @state thing means, a binding to it. And so that's why we're able to pass it. If I didn't put that $sign there, the compiler would say something trying to pass int to binding. Types don't match. Okay, $my data is a different type thing. It's a binding to an int in this case. Yeah.
What does @state mean? Or is that just something that the class keeps track of?
Yeah, I talked about this before. @state is actually just a little macro that makes two variables for you. One is a little var of type state. It's a struct. Okay, it's type state that has got a class pointer inside of it. Okay, and that class pointer points into the heap and keeps that little piece of data for you. And that little var it creates is called underbar, the name of your thing, and you're going to see that here with binding as well. And the one without the underbar is just a little thing that accesses the data from the state in the heap. So it's just a way to indirect things into the heap. That's what @state does. That's why that's the only way we can have writable data inside a view, because views are lets. They're read-only. Okay, they're read-only structs. The only way we can do it, having that little @state. Yeah.
Is there a reason to use binding if you just intend to read a value but not write it?
So the question is, would I ever use @binding if I was only going to read foo? If view B never wrote to foo, it would never use an @binding. @binding is only for read-write connectivity. That's all it's for. So let's talk a little bit about binding here. One interesting thing about binding is it is legal to have a binding to a binding. So you can say $a binding, like $foo. That works. Okay, it binds through the binding to the @state. So it's basically the same as a $sign to the original my data. That is legal. So that means that views that you share your data with, they can turn around and share it with other people too. You can't stop them. Yeah, this is what I was saying about @state. So here it is for @binding. @binding is creating a little binding of int. Okay, it's a generic type, right? Binding is generic type, like array is generic type. So a binding of int is what's creating there, called underbar foo. And inside there is where the magic code that links over to that $sign state thing is happening. And then the actual bound data, I say now named bound data, but that's wrong. It should be named foo with no underbar. That thing is just a computed var. It's computed using the binding thing to get back at it, right? It's a computed property that's both get and set, which we haven't seen. We've only seen get only ones like var body, but that's what's going on there. So yeah, that underbar foo, it's like the underbar for the state thing. I'll show you what that looks like. Like we sometimes access those in an init, but don't worry about that for now. The opposite thing with binding here, never have private with binding. In fact, a compiler probably won't even allow you to do that. And it makes sense, right? Because a binding is someone passing you a binding to their data, so it has to be accessible to them. It can't be private. How would they pass it to you? Okay, so it makes no sense to have a binding that would be private. compiler probably will not even allow it. So it's the opposite of state. Binding never has private, state always has private. You can create constant bindings with .constant, which is a static func on binding. So here I've created this binding angle brackets int because it's generic. .constant 5, that's a binding to the number 5. So even if someone tries to change the value of it, it will not change. It will always be 5. It's constant binding to a constant. All right, passing data using functions. I'm going to have to zoom through this really fast. It's pretty obvious, really. Some functions are give something functions, okay, functions that the view that you're handing the function to is going to call to give you something, and some of them are get something functions, okay, like VStack's content argument is getting something. Give somethings are not that uncommon. I'm going to do this on Wednesday so you can see what this is like. Get something is more rare. You see it with view builders. Of course, view builders are all get something kind of things, but give something kind of, they are get something kind of things, but we don't really use them that much. This slide, I'm just going to basically skip over. You can have it in your things to go look back when we get to this. But eventually we're going to get to a problem where we're passing a function to an init or to another function, and that thing is going to hold on to that function. Okay, it's not going to immediately execute it. It's going to hold on to it and call it later, like a button does. You give it the thing, it doesn't call it till later when the button gets pressed. And when that happens, you have to mark that thing as @escaping. In other words, it escapes this lexical context that it's in. And that lets Swift know that it needs to put that thing in the heap. So this might stun some of you, but a closure has reference semantics. Okay? It's not a class. It's not related to a class in any way. Classes have reference semantics. Closures have reference semantics. And the reason is that they need to possibly live in the heap and store all those local vars that they capture in the heap so that they're with them when they're called later. Okay? So that's why that's true. And then this thing at the bottom is how you can make a function be an optional function. You just put parentheses around a question mark. Now it's an optional function. And the way you call it is by putting the question mark after the name of the function when you're calling it. Okay, and I'll show you that in demo as well. I've talked about all this stuff, and I haven't mentioned the most important way to share things between views, which is this thing called @observable. Okay, and that's really how we're going to share things, and I will show you @observable. We are going to make our code breaker be an @observable in a couple of weeks. But I just don't want anyone who knows Swift, who's watching this presentation and saying, what? @ binding, great, but what about @observable? It's the world's greatest sharing thing. And yes, it is. I don't want to say, it's just that you haven't learned it yet. And I haven't taught it basically. @observables is basically like @ binding, but for classes, okay? For things that have reference semantics. And that is it for today. Went over a little bit, sorry there. And Wednesday is going to be all demo, and I'm going to show you all this stuff, all this data flow stuff. We'll do @ binding and functions, passing things, and all that stuff. All right? All right, see you then.